In this lesson, we're going to learn how to find derivatives of trigonometric functions. The two main rules we want to remember are that the derivative of sine x with respect to x is equal to cos x, and that the derivative of cos x with respect to x is equal to negative sine x. So we want to determine the derivatives of each of the following functions. So the first one, y equals cos x, the derivative is negative sine x. That's just a straightforward application of one of our rules. In this question, we want to figure out the derivative of the function x sine x. Well, this is a product rule situation. We have the function x times the function sine x. So we go the derivative of the first function, which is the derivative of x, times the second function, which is sine x, plus the first function, which is x, times the derivative of the second function. Since the second function is sine x, the derivative will be cos x. And when we simplify this expression, we get sine x plus x cos x. The next one is y equals sine of x squared. Well, this exponent of 2 is applying to the x. So what we're actually going to do here is use a chain rule. We're going to figure out the derivative of sine, which is cos. So the derivative of sine block is cos block times the derivative of that block. The derivative of x squared is 2x. So it's cos block times 2x. And a mistake sometimes people make is to think that x squared is multiplying 2x. That's not the case. Cos x squared as a quantity is multiplying 2x. So just to make things a little bit easier, I like to put that 2x in front. This is actually equal to 2x times the cos of x squared. Now, the sine of x quantity, the sine of x squared is different than sine squared of x. When we say sine squared of x, we're evaluating sine x and then squaring it. So we're going to use a chain rule here. We're going to bring that 2 in front. The derivative of block squared is equal to 2 block. But then we also have to multiply by the derivative of that block, a classic chain rule situation. So it's 2 times sine x times the derivative of sine x, which is cos x. The next question is to figure out the derivative of the cosine of 1 plus x cubed. Well, this is a chain rule situation. Whenever the angle is not simply x or whatever variable is in play, we're going to have to figure out the derivative of that angle at the end of the question. So the derivative of cos block is equal to negative sine block times the derivative of that block. So the derivative of 1 plus x cubed is 3x squared. But again, I like to point out that the 1 plus x cubed is not multiplying the 3x squared. The 3x squared is multiplying this entire quantity. So I take the negative 1 in front, I multiply it by the 3x squared, I get negative 3x squared. And now this 1 plus x cubed is the angle it's connected to the sine. So I get negative 3x squared times the sine of 1 plus x cubed. The next question is to figure out the derivative of tan x. Well, I like to re-express tan x as sine x over cos x, and then I use the quotient rule. It's the denominator times derivative of the numerator minus the numerator times derivative of the denominator over the denominator squared. Well, cos x times cos x is cos squared x, and negative sine x times negative sine x is positive sine squared x. So we have cos squared x plus sine squared x over cos squared x. This is 1 over cos squared x, which is also known as secant squared x. So the derivative of tan x with respect to x is secant squared x. Our next question is to determine the derivative of cotangent x. So much like the last question, we make cotangent x cos x over sine x, and we use the quotient rule. The denominator times derivative of the numerator minus the numerator times derivative of the denominator. And when we simplify, we get negative sine squared x minus cos squared x in the numerator over sine squared x. Well, we can factor the -1 out, and we have sine squared x plus cos squared x in the bracket. And that sine squared x plus cos squared x in the bracket is the same as 1. So we have -1 over sine squared x, and that's the same as negative cosecant squared x. Next, we have y equals cosecant x. We want to find the derivative of that. So we can think of that as 1 over sine x. Now, we can use a quotient rule approach here. I decided to use a chain rule approach. I called 1 over sine x quantity to the exponent -1. And we'll use a chain rule. The derivative of block to the -1 is negative block to the -2 times the derivative of that block, which is cos x. So we get negative cos x over sine squared x. That's the same as -1 over sine x times cos x over sine x, which is the same as negative cosecant x cotangent x. And finally, we will figure out the derivative of secant x. Secant x is the same as 1 over cos x, so we'll again use a chain rule approach here. That's the same as cos x quantity to the -1, and using a chain rule approach, we bring that -1 in front, subtract 1 from the exponent, so the derivative of block to the -1 is negative block to the -2, but we have to multiply by the derivative of what's inside. And the derivative of cos x is negative sine x. So what we end up with is negative sine x in the numerator. We have negative cos squared x in the denominator. Obviously, a negative over a negative, we're going to have a positive quantity. So we can call this 1 over cos x times sine x over cos x, and that's the same as secant x tan x. Now, these next questions get a little bit more complicated. We have y equals sine x cos x. This is a situation where we want to use a product rule. The first function is sine x, and the second function is cos x. So we figure out the derivative of the first times the second, so that's cos x, plus the first times derivative of the second. So the first function is sine x. The derivative of the second function is negative sine x. So we end up with cos squared x minus, because there's a negative sign there, sine squared x. The next one, we have the next question, B, we have y equals sine x times cos squared x. Well, that's the same as sine x times cos x quantity squared. So we're going to use a product rule here because we have a function times a function. And then we're also going to have to use the chain rule within the product rule. So the derivative of the first function times the second function gives us cos x times cos x quantity squared. And then the first function times the derivative of the second function, that's sine x times, now we have to figure out the derivative of cos x quantity squared. Well, block squared's derivative is 2 block times the derivative of the block, which is negative sine x. So this negative sine x is not multiplying x. Cos x is its own entity. So what we can do is think of this negative sine x as multiplying that sine x, and this 2 cos x is kind of on its own. So we have the coefficients 1 and 2 and -1. When we multiply those, we get -2. And we have sine x times cos x, which is sine squared x cos x. And the first part, cos x times cos x quantity squared, is cos cubed x. Okay, now for the next one, we want to, we have y equals the sine of cos x. Now this is a little bit different. This one's tricky. A lot of times people think this is time to use the product rule, but it's not. This is not a situation of product rule. This is a chain rule. What we have is a composite function. We really have f of g of x, where f, so to speak, is sine and g of x is cos x. So what we want to do is think of the chain rule this way. F of g of x as a quantity prime, in other words, the derivative of f of g of x, is f prime g of x g prime of x. Well, that's going to help us. So if we think of f as being sine, then f prime is cos. So we have f prime g of x, cos x, times f prime of x, times g prime of x. The derivative of cos x is negative sine x. So we have the cos of cos x times negative sine x. So we can take this and put it in front. That's kind of a good thing because it reminds us that this negative sine x is not multiplying cos x. Cos x is the angle to cos. This is its own entity here. But that negative sine x afterwards is multiplying the entire result. So we can take the negative sine x, put it in front, and we call it negative sine x times the cos of cos x. All right, another question, kind of a tough one, is our function is y equals tan x times the sine squared of cos 2x. Well, that's like saying tan x times the sine of cos 2x quantity squared. Well, we're going to use here a product rule. The first function is tan x, the second function is the sine of cos 2x quantity squared, and then while using the product rule, we're going to use the chain rule multiple times. So we're going to have the derivative of the first function, which is secant squared x, times the second function, which is sine of cos 2x quantity squared, or in other words, sine squared of cos 2x, plus the first function, which is tan x, times the derivative of the second function. Okay, now here's where we're going to make our money. The 2 comes in front. This is essentially block to the exponent 2, so that it's 2 block to the exponent 1. But then we have to multiply by the derivative of the block. Okay, well, the derivative of sine of cos 2x, think of this as f of g of x. So we're going to have f prime, which is cos of 2x. But we, in determining this derivative, we now have to determine the derivative of that angle. So what's the derivative of cos 2x? The derivative of that is negative sine 2x. The derivative of cos block is negative sine block, but we also have to multiply by the derivative of that block, which is 2. So there was 3 or 4 chain rules there. One thing to kind of remember is the innermost angle here is 2x, and when you're doing those multiple chain rules, you're done when you've written down the derivative of that innermost angle. So the innermost angle here, with the sine cos of 2x, the innermost angle here was 2x, so we had to keep on going until we gave the derivative of that, which is 2. Well, we can simplify this a little bit. This is secant squared sine squared of cos 2x. And then here, we're just multiplying a bunch of quantities. We've got a positive 1, a positive 2, a positive 1, a negative 1, and a positive 2. So multiplying all those coefficients gives us negative 4. And then we have tan x sine of cos 2x. We have tan x sine 2x. And so yeah, tan x sine 2x, and then we have the sine of cos 2x and the cos of cos 2x. Those kind of questions take a little bit of practice. And finally, last one here, we have y equals cosecant of 4x squared minus 5x plus 1. Well, we know the derivative of cosecant x is negative cotangent x cosecant x. That was one of the questions we did at the start of this lesson. So the derivative of cosecant block will be negative cotangent block cosecant block times the derivative of that block. And the derivative of the block is 8x minus 5. So the innermost angle is 4x squared minus 5x plus 1. We gave the derivative of that, and that's kind of when we knew we were done using the chain rule. And again, I don't want to get confused and think I'm multiplying this by that. That's not the case at all. So I'm going to put this 8x minus 5 factor in front. And so I've got negative 8x minus 5 blocked. And then the cotangent of 4x squared minus 5x plus 1 times the cosecant of 4x squared minus 5x plus 1.